Hey guys, this is Miss Smith. We're going to be doing Unit 7.1, Linear Relationships in the form of y equals mx plus b. Alright, let's define linear relationships. This is a relationship between two quantities, or numbers. As one quantity changes by a constant amount, the other quantity also changes by the same constant amount. Okay, this is really confusing. Let's just think of linear relationships as it makes a straight line on an x and y graph. Okay, so it makes a straight line on an x and y graph. So that's what we really need to know about linear relationships. And there are two types of them. The one type that we have learned, it's called proportional. This should be review. So a proportional relationship, remember, is in the form of y equals kx. So we have already done this. This is review. So now we're going to be learning another type. Okay, starting out with an example first before we get into too detailed. Let's read the problem here. It says, use table below. Susan's grandmother gave her $25 for her birthday. Instead of spending money, she decided to start a savings program by depositing $25 in the bank. Each week, Susan plans to save an additional $2.50. Okay, so when Susan's grandmother gave her the money, where do we start at when it has not been a week? We start out and put it in the bank. Good, it'd be $25. Okay, so that's how much she has saved. We're going to have S represent amount saved and W represent our weeks. Okay, so if we have 1 week, how much do you think she has in her bank account? Well, in my head, I know that if each week I plan to save $2.50, I'm just adding $2.50 to 25, right? So we got to make a process to, no matter what, No matter what week we want, we need to find a rule to help us get how much we saved. Now, we did this in our head, but what if we jump to 3? Well, we need a process. So, if I know that I have $25 already in my bank, and I am depositing $2.50 each week, well, what about $2.50 times 1 week plus what I already have in there, which is 25? So 25 pretty much stays the same. We know we always had 25 to start out with, and then each week we're adding $2.50. So what about if we save for 2 weeks? Well, it'll be $2.50 times 2 weeks plus 25, because we know this 25 stayed because we started with it. Okay, it's our starting amount. So now $2.50 times 2 plus 25 would give me $30. Oops, I don't know why I put a 5 there. Okay, what about week 3? Well, I see a pattern here. We know we're going to multiply $2.50, which is how much we're adding each week. We got to multiply that by how much I'm adding. So $2.50 times 3 plus $25. This time this would get me $32.50. Okay, can someone look over here at amount saved and tell me if you see a pattern, what happens from $25 to $27.50 to $30 to $32.50? Good. We have a rate of change. And this is each time we add $2.50. Makes sense, right? Because each week we save, or we put in $2.50 an additional amount because we started with $25. All right, so let's write a rule for the amount of money Susan will have after W weeks. Now, you're probably asking, well, Ms. Smith, this W, we don't have a number. Well, we can put any number we want. Let's say you wanted to know how much money you would have in 52 weeks. Well, this is why this W is a variable. So we can put any number here, and we can get how much we saved. So the rule is we are doing it in the form of y equals mx plus b. Kind of looks like this, right? So what do you think our m is going to be in this problem? Because these are the two things we're changing. Good, it would be $2.50 or 2.5, I'm going to take off that 0, times x, which x is going to be, whatever week. So instead of x, I should probably change this to x since I'm using this as the weeks. So $2.50 times the amount of weeks plus what I had in there at the very beginning, or the starting point, is going to be plus 25, which represents B. Okay, we will define these in just a minute after we finish this. Okay, now that we know how to create a rule, is this relationship between time, our x values, and amount saved, our y values. So in reality, we did an x, y chart. I added this in here to make you see what you're doing. Okay, so is this proportional or non-proportional? And how do we know? Well, it's non-proportional, because I told you we were learning something new this week because you've already learned proportional, but it's non-proportional because why? Well, first I see that it does not start at 0, 0, does it? My table would look like this. 0, 25 for my x and y. It'd be 0, 25, 1, 27.5, 2 would be 30, and so forth. So a proportional relationship always starts at 0, 0. So we know that it does not. So that's a quick way to realize, is it proportional or is it not? So how much money would Susan save after 5 weeks? Well, we know that weeks is represented by, I kind of messed up, it's represented by W, but in this case we did it represented by X. So my formula is Y equals 2.5X plus 25. That's what we got from up here. So I know that I'm going to plug in 5 to where? Good, my X value, or we could have used W, but it'd be 2.5 times 5 plus 25 is going to give me, and of course order of operations tell me I got to multiply first. So this would be, pause me and do it by yourself and let's see what you get. Okay, good. You would get $37.50. That's how much you would save in this problem in 5 weeks. Okay, now I'm going to go over this, pretty detailed because I want y'all to know that y'all have already learned this. Right here, y'all have learned. So there are 2 types of linear relationships, which just mean we're talking about a straight line. That's all linear means. So there are 2 types, proportional, which we've already talked about, that go through 0, 0, and we use it in the form of this. So where the variable k is the constant rate of change, or we also call it the constant of proportionality, or it is our unit rate compared to 1. So we know that it always goes through 0, 0, the coordinate pair 0, 0 on a graph. And it is a straight line, of course, since it's linear. Okay, now something new is our non-proportional relationships. This is represented by the formula y equals mx plus b. And in this case, it does not go through the origin 0, 0. Okay, because the plus b makes it not go through the origin. So doesn't this part kind of look familiar? Kind of looks like that, but a different variable. So the plus b makes it not go through the origin. So right here is what we have to memorize. Right here, this is our formula for non-proportional. Okay, so we have our m, which is going to be represented by the rate of change, or it's also called the constant rate of change. We do ROC for rate of change, so it kind of spells out rock. So when I say rock in class, you'll know that means the rate of change. And then B would be our starting value, or when x is 0, and we also call it the y-intercept. So in this case, in our last problem, we had y equals 2.5x plus 25. So B would be the 25 in that problem, and m would be our constant rate of change. Because think about it, each week you add $2.50, so that is the rate of change each week. You started out with 25, and then we're doing this each week. So that means that is going to be my rock, or my rate of change. Okay, so now we're going to go into detail with non-proportional relationships using this formula. So let's do example 2. It says the yearly cost of a community college based on the number of credits, which number of credits are, what your classes, how many hours your classes are worth. So it's just pretty much classes. Taken are shown below in the table. Mine is on the next page. So we're going to use the table to calculate the y value is when x value is 0, and give the new equation, which is this, in the non-proportional form, y equals mx plus b. So we're going to use the table to give a verbal description of the relationship between credits and cost. Okay, so we know our table can look like this with an XY going like this. We've already learned this. Or it can be a vertical table like so. All right, so I want you to copy this down step by step. So we're going to look for patterns in the different values for X and Y relationships. In this table, each value for credits are 3 greater than the previous one. So how do I jump from here to here? How do I jump from here to here? Well, we're adding 3, right? So that is what happens with my X values. And then each value cost $75 greater for each previous one. Okay? So this means, and I want y'all to mark this out on your paper. I think I already marked it out when I copied them, but we're not going to do that for this. But this means that the credit for 1 to $25 in cost. So 1 would equal, well, $25. So we know that 1 is to 25. Now, determine how many more dollars than 75 that it costs to take 3 credits. So it cost 175 minus 75 equals 100, more than 75 to take 3 credits. This sounds confusing, doesn't it? Well, we're going to do so many examples in class, so if this is confusing to you, we will definitely go over it. So the thing you need to know, guys, is this part. Okay, so we're going to be doing a written description, because now that I read this is kind of confusing. So let's look at step 3. Says give a written description for the relationship between X and Y values. So that's talking about credits and cost. So the yearly cost of the community college is, we started out at 0 with $100. Okay? Plus $25 for each credit. So we know that our equation is going to be, if I take this verbal description, it's going to be 100 plus, here's my keyword each, plus 25 for each credit. I'm going to use C for credit. So see, this is kind of backwards from our problem, isn't it? Okay, so we are going to, rewrite it so we know that it means this. So we have Y equals, now C is going to be changed to X plus 100. So we have Y equals 25 times X plus 100 is going to give me anything up here. Okay? We're going to do so much practice, you guys. So, and I already went over this with my class, in class today. So this part kind of sounded confusing, but we will do a lot of practice. So look at the ones before this with the table, and hopefully the Google Doc you can figure out, okay? Y'all have a great night, and don't forget to do your quiz and submit. Y'all have a wonderful night. Bye.